This video is part of a self-paced learning program on scientific shoemaking. Shoemaking involves a number of distinct steps. The process involves designing, pattern making, and pattern grading. Cutting. Skiving. Stitching. Lasting. And sole unit attaching. The end product, the shoe, is the result of these basic steps. We are going to look at the principles of skiving and operation of the single-step cylinder knife skiving machine. Skiving is the process of reducing the thickness of the cut edges of the upper component. It is also used for reducing the thickness of toe puffs and counter edges. It's an important operation while preparing the uppers for stitching. Good skiving means a qualitatively better upper. Studies indicate that incorrect skiving is responsible for a high rejection rate. The skive is shaped by the work gauge and the feed roller. The knife removes a portion of the material to give a skive. Its purpose is to improve the appearance, to make footwear more comfortable, to reduce bulkiness and make stitching and folding easier, to aid construction during lasting, and to help in better adhesion. Because of the importance and purpose of skiving, it's an operation that has been practiced even before the machines were invented. It was done manually. Here we shall discuss skiving theory, comprising the terms commonly used and the types of skiving. Means for skiving, covering the system types, the single-step machine, parts and functions, and machine operation and safety. Application, highlighting machine setting and skiving, and defect analysis. Work management, dealing with machine maintenance and tools. Points to watch, and organization and ergonomics. Coming to skiving theory, familiarization with the terminology first. This is the grain side of the material, the flesh side, the width of skive, the depth of skive, and the angle of skive.
Now let's talk about the various skives. This is skive for the open edge This skive is for the closed seam. This skive is for the blind seam. This is the burnished edge skive. This is skive on light leathers. This skive is for heavy leathers. This is folding skive for the shallow bagged edge. And this is the underlay skive.
The skive types are grouped as shown here. Edge skive, comprising open edge, back seam, blind seam, and burnished edge. Fold skive, comprising grooved and bagged roll top. Underlay skive, comprising lap seam, toe puff and counters, and the lasting margin. Open edge is used for achieving a uniform appearance along the raw edges visible on the finished shoe. After skiving, the edge is stained to match the upper color. Normally, the width of the skive should not be more than 1.5 millimeters, and the depth should be 1/3 of the total thickness. Back seam. On light leather, skiving is done only to take off the fibers, that is, for materials below 0.8 millimeters. But on heavy leather, above 1.8 millimeters, enough material must be skived to reduce strain on the seam and to reduce bulk. Normally, the depth of the skive should not exceed 1/3 of the material, and the width about 2 millimeters. Blind seam. In this case, the components are stitched face to face. One component is skived for an open edge and the second for a fold, so that after stitching, the top piece can be folded over, as shown here. Burnished edge. This is done on edges to give a folded appearance. The reduction of material allows the edge to curl when heated. The skiving is done at an angle of 40 to 45 degrees. A fold skive is done on edges to be folded, so that the final thickness is the same as the rest of the component. The width of the skive is normally twice that of the fold. On light leather, the skive for folding is different from that for heavy leather. On light leather, the skive tapers down to 30% of the thickness. The width is twice the fold. On heavy leather, the thickness of the skive is reduced to 50%, while the width is twice the fold, plus 1 millimeter for the rollover. A grooved skive is done by a special foot meant for the purpose. It provides a guide for folding. For a bagged roll top, the upper component is skived as for a fold, except that the width in this case is less. and the thickness more. An underlay skive is done to reduce the substance at the edge of a component, where it has to be laid below another. For lap stitching, the component to be underlaid is mostly skived on the flesh side. On unlined shoes, it is done on the grain side. The depth of the skive is as much as the thickness of the material, as it tapers down to a paper-thin edge. The width of the skive should be such that the first row of stitching can pass through the full substance. The skive must be at least 1.5 millimeters behind the stitch mark. Toe puff and counters. Counters and toe puffs are skived for an underlay skive, as shown here. The lasting margin is skived to help reduce the bulk and ease pleating when the upper is lasted. To recapitulate, skiving reduces the thickness of the upper component edges. It has multiple purposes, leading to improved appearance and easier upper preparation. There are different types of skives grouped under edge, fold and underlay skives. The rest after a break. The means for skiving covers system types, single-step machine, parts and functions, and machine operation and safety. The system types are the metric system, using the band knife, the hand-guided, which could be manual or machine, employing the cylinder knife or the disc knife, and the three-step skiver and the single-step skiver machines in current use. In matrix skiving, the work is placed in a template and passed through a band knife which gives the corresponding skive. The disc knife is a cutting device. Notice the direction of the work and the direction of rotation of the disc. This method is now obsolete. The cylinder knife is commonly used in modern machines. Notice the direction of rotation of the knife and the direction of work. The three-step skiver can give various skives in one operation. Different skive angles and thicknesses can be preset. The sequence of cuts can also be preset. Variations to the basic cuts, like edge, fold, and underlay skive, can be derived by making adjustments. Coming to the single-step skiver, let's take a good look at it. The front view. the side view right, the rear view, and the side view left.
This machine, like all others, is run by a clutch motor which transmits power when the treadle is depressed. This treadle should be connected by a pitman's rod and not a chain and hook. The main parts of the machine are the feed roller, which feeds the work onto the machine. This is held under tension by a spring and a hook. The tension can be varied by adjusting the slots. The softer the material to be skived, the lighter the tension. The feed roller has to be as close as possible to the knife without touching it. For this purpose, there are feed roller adjusting screws, each with a locking nut. The front screw alters the angle of the feed roller, and the back screw adjusts the depth. The pressure foot holds the material to the cutting knife and determines the amount of material to be cut off. It can be raised or lowered by the lifter. It is held in position by means of a spring clip. The pressure foot can be adjusted by means of two screws. The screw at the back adjusts the angle to obtain a thinner or thicker skive. The screw on top of the arm is meant for obtaining a thinner or thicker edge. The guide determines the width of the skive. It has a locking thumb nut and can be moved forward or backward to obtain the desired width. The cylinder knife skives the material. It rotates away from the operator and can be moved forward or backward towards the pressure foot. It should be as close as possible to the pressure foot without touching it. The knife, in order to give a clean skive, must be very sharp. The bed is a resting place for the skived components. The belt cover is a safety guard to protect the operator from the driving belts and pulleys. It is held in place by a thumb nut. There are 3 drive belts. For a clearer understanding of the drive belts, we will view it from the inside. The main drive V-belt moves the knife. The second belt drives the feed roller, and the third belt moves the sharpening stone. The speed of the feed roller can be changed by moving the belt onto the next set of pulleys. The hand wheel enables the operator to turn the machine by hand. The sharpening stone is used for sharpening the knife. it should always spin away from the knife edge. The adjusting thumb nut moves the stone forward or backwards for sharpening the knife.
Pressure foots are available in a wide variety to suit different skives. They can be grouped into 3 types: normal, with roller, and with groove. Special attachments like rollers are used for skiving towpuff and counters. Feed rollers are also of 3 types: emery, metal, and rubber. Emery stone for leather, metal for towpuff and counters, and rubber for soft materials. Machine operation and safety. Before operating the machine, always check that the sharpening stone is not touching the knife. And pass a paper to check that the knife and foot are not touching the roller. Turn the machine on. Adjust settings. Feed the leather with the grain side up. Keep the leather to the guide and run through. Allow the machine to feed the work through. The belts must be covered to prevent clothes entangling. Never place your hands near the knife. Use a brush to clear leather dust around the knife. Keep the work area tidy. Collect scarf in a metal bin. Know your fire drill. And switch off when not in use. To recapitulate, there are different means for skiving. Familiarize with machine parts and functions, and follow the correct procedure for skiving. The rest after a break. Application, comprising machine setting and skiving and defect analysis.
Now let's see how the machine can be set to achieve the different widths and thicknesses required for the various types of skives. The width of the skive can be increased by lowering the height adjustment screw and shortened by raising it. The width can also be increased by lowering the angle of the pressure foot. Moving the guide wider also increases the width of the skive. The thickness of the skive can be increased by raising the height adjustment screw or decreased by lowering it. Moving the guide forward reduces the width and increases the depth. Raising the angle of the pressure foot increases the thickness of the skive. Angle of skive is obtained by lowering or raising the height adjustment screw.
Edge skive is usually obtained by just raising the pressure foot and adjusting the guide. For a fold skive, the foot should be parallel to the roller. The width should be twice the fold. Skive for light leather. Skive for hard leather. An underlay skive requires the foot to be raised slightly in the front and depressed in the center. Adjust the guide. Toe puff and counters are skived for an underlay. Toe puff splitting in progress. For splitting on the single step skiver, the guide is removed. Adjust the pressure foot parallel to the knife. And now for the common faults. Width too wide. Result, after folding, it leaves a gap. Pressure foot angle low. Raise angle. Guide set wide. Adjust guide. Pressure foot height low. Raise height. Width too narrow. Result, ridge after folding. Pressure foot height and angle high. Lower height and angle. Guide set narrow. Adjust guide. Width variable. Incorrect guiding. Keep to guide. Blunt knife. Sharpen it. Clogged feed roller. Clear blockage. Worn machine parts. Refer to mechanic. Edge too thin. Result, creates a hollow after folding. Pressure foot angle and height low. Raise angle and height. Edge too thick. Result, ridge after folding. Pressure foot height and angle high. Lower height and angle. If the height is all right, then the guide is set narrow. Adjust guide. Edge irregular. Guide not set properly. Adjust guide. Blunt knife and position too far. Sharpen and adjust. Feed roller low and set too far. Adjust position. Ridge on skive. Blunt knife. Sharpen it. Clogged feed roller. Clear blockage. Worn machine parts. Report to mechanic. Glazing on leather. Blunt knife. Sharpen it. Workpiece sticking. Apply Teflon tape to foot.
Let us now see how skives are related to footwear. A finished shoe with aesthetic appeal, wearing comfort and durability requires a wide variety of skives. Here we shall do a destructive demonstration to show the use of these skives. Here are two shoes, one employing the invisible seam. The invisible seam looks like this from inside. Observe the use of the skive to give a finished, smooth appearance. The upper, in case of a heavily designed shoe, looks like this from inside. Notice the different skives employed both on the inside and the underlay to give a nice, smooth and aesthetic appearance. Notice how skiving is used for mats, which are employed as a part of footwear for decoration purposes.
To recapitulate, there are different settings for edge, fold and underlay skives. Different skives can be obtained by making adjustments. Defects are due to faulty adjustments. The rest after a break. Work management covers machine maintenance and tools, points to watch, and organization and ergonomics. Good machine maintenance reflects in the quality of the shoe manufactured. Special attention needs to be given to this aspect. The following should be attended to. The knife should be sharpened regularly. Never stop the machine while sharpening. Use a dressing tool to clean the sharpening stone. The knife position should be adjusted after a sharpening operation. Undo the locking lever pull the anvil pin and pull out the bracket. Clean the feed roller and, if necessary, change it. Replace the bracket into position. Lubricate the machine by topping the gearbox with grease and oil through the oiling points. Oiling should be done daily. Points to watch. Thorough operator training is essential. Ensure that the operator looks for variations in the thickness and width for readjustment. Use Teflon tape over the pressure foot for soft and patent leather. Remember, different types of leather suit different skives. Always organize the work area before commencing work. The shop floor should have enough movement space and should be well lit. Arrange logistics at the place of work of the operator. Automation allows uninterrupted workflow. Inter- and intra-activity grouping minimizes coordination problems. Proper layout for a left-to-right flow increases productivity. Correct skiving method enhances effortless operation. The sitting posture should avoid uncomfortable thigh angles. The arms should flex naturally to avoid strain. Position lights to avoid hard reflections and shadows. Utilize specification charts. To recapitulate, preventive maintenance minimizes downtime. Check for variations in standards and increase productivity through ergonomic methods.